Hi, and welcome to AstroTeach, where we try our best to provide the finest education. Hope you enjoy your learning journey.
The life cycle of the stars. Mass determines a star's temperature, luminosity, and diameter. In fact, astronomers have discovered that the mass and the composition of a star determine nearly all of its other properties. And now, we want to take a look at the life cycle of a star. The changes that a star goes through are determined by how much mass it has. There are two types of stars based on their masses. The first group is average star, which is a star with relatively low mass. And the second group is massive star, which is a star with relatively high mass. But how the formation of a star begins? The formation of every star begins with a cloud of dust and gas made of 97% hydrogen and 3% helium called the stellar nebula. Gravity causes the nebula to contract. Therefore, the atoms lose potential energy. And so, the loss of potential energy causes an increase in temperature. And now we want to know about protostars. As the cloud contracts, its rotation forces it into a disk shape with a hot condensed object at the center called a protostar. And finally, the main sequence begins. Eventually, the temperature inside a protostar becomes hot enough for nuclear fusion reactions to begin. Once this reaction begins, the star becomes a main sequence star and stable because it then has sufficient internal heat to produce the pressure needed to balance gravity. When the temperature is high enough, fusion of hydrogen occurs and helium is created. The energy is released when hydrogen fusion occurs. This again causes an increase in temperature. And when the temperature is high enough, the helium nuclei also begin to fuse, releasing more energy. And what about fusion? Fusion reactions involving elements other than hydrogen can occur. Once a star's core has been converted into helium, helium might fuse to form carbon if the temperature is high enough. At even higher temperatures, carbon can react with helium to form oxygen, then neon, then magnesium, silicon, and finally iron. And then the main sequence maintains. The balance between gravity squeezing inward and pressure from nuclear fusion and radiation pushing outward, called hydrostatic equilibrium, must be held for a star to be stable. Otherwise, the star would expand or contract. And so, what happens when a star's main sequence comes to an end? When stars run out of hydrogen, main sequence ends. The core contracts and the shell expands about 100 times bigger to maintain equilibrium. It takes about 10 billion years for a star with the mass of the Sun to run out of hydrogen. The temperature increases and helium burning begins. And so the process that the star goes through from now on depends on its mass. And so, what's the death of an average star like? An average star, or a low-mass star, is condensed in a nebula and begins a nuclear reaction that causes hydrogen to form helium, releasing energy in the form of heat and light. A low-mass star will stay in this main sequence phase for a long time, until it begins to use up all of its hydrogen. Towards the end of its main sequence phase, a star begins to burn all of its hydrogen. The outer layers will collapse, become heated by the core and expand out, forming a red giant. The star begins to quickly blow off its layers, forming a cloud around the star called a planetary nebula. and the star in the center of the nebula is very hot but not very bright. When a star has burned all of its fuel, it will collapse under the pressure of gravity. The white dwarf that forms is very small and dense, and it will eventually cool to form a black dwarf. But there is probably a difference between low-mass stars and high-mass stars. Stars with more mass than the Sun, or high-mass stars, burn their hydrogen faster than low-mass stars, so their main sequence phase is much shorter. These stars burn hotter and brighter than low-mass stars. When the high-mass star burns off its hydrogen, its outer layers begin to expand rapidly. Temperatures at the core are much higher than a red giant. Nuclear fusion causes elements to combine into an iron core at amazing speeds. The iron core collapses on itself under the intense gravity at very high speeds. The energy released is called supernova. And as we get close to the end of the life cycle of a star, we should know that after the incredible release of energy from the supernova, a dense core 1 trillion times denser than a white dwarf is all that remains of the massive star. If the mass is too dense, it will continue to collapse on itself, forming a black hole. The gravitational pull of a black hole is so great that even light cannot escape.